Safety in the field and workplace is an important component of any stormwater investigation. Tasks such as locating outfalls, collecting and testing stormwater samples, and assessing stormwater systems present a variety of hazards. Some hazards include noxious plants such as poison ivy and poison oak, uneven and slippery terrain during dry and wet weather conditions, and at times exposures to sanitary sewage containing pathogenic bacteria and viruses, along with other hazardous contaminants. The following slides will address these hazardous conditions as well as other common hazards found in the field. We'll also discuss methods to prevent exposure and limit risk. One of the most common hazards found in the field are noxious plants. Noxious plants are those that are harmful or cause irritation. Plants such as poison sumac, poison oak, poison ivy, and thorns are the most common of these bothersome plants. Oils from noxious plants are easily transmitted by touch. Personnel should familiarize themselves with the characteristics of each plant and avoid contact. Simple prevention measures include closed-toe shoes, long-sleeve shirts, and long pants. Another hazard while working in the field are ticks. In early May, dog and deer ticks become active and stay active until late in September. However, ticks are a hazard year-round in south coastal communities. Diseases such as Lyme disease, anaplasmosis, babesiosis, and Powassan virus are all illnesses derived from the bite of a tick. As with noxious plants, wear closed-toe shoes, long-sleeve shirts, and long pants while working in areas where ticks reside. An extra precaution is to spray clothing with clothing insect repellent spray like permethrin. These repellents are often strong enough to last several wash cycles and should never be sprayed directly on the skin. Spray clothes and shoes, then let air dry before wearing. Another common field hazard is the navigation of rough terrain. Climbing down embankments or navigating rocky regions increases the risks of slips, trips, and falls. These risks intensify in wet weather. Wear footwear with traction and support designed for wet, rocky terrain. In addition, the use of a sample pole can ensure further protection. A sample pole provides an extension of reach in any direction. In a scenario where an outfall is located on the side of a steep hill or a cement block, the sample pole would be used to lower the collection cup from above. This avoids the hazards posed by climbing down and back up a steep embankment or a wall. The pole can also be used to extend outwards, allowing an individual to avoid thick brush, noxious plants, and unnecessary entry into waterways. Adjust the sample cup holder at the end of the pole to fit a variety of angles to collect a sample directly from a discharge pipe. This allows for successful sample collection while avoiding potential risks imposed by the outfall's immediate surroundings. Always use sanitary gloves when collecting samples to protect yourself from bacteria, viruses, and other pathogens frequently found in stormwater. Sources of pathogens include illicit sewer pipe connections, septic tank overflows, domestic animal or wildlife waste, and other sources. During wet weather, pathogens are transported with stormwater and discharged from outfalls and can pose a potential health risk. A new set of gloves should be used at each site to avoid cross-contamination between samples, as well as to minimize the spread of pathogens on commonly touched surfaces. In addition to gloves, reflective vests should be worn at any site in close proximity to a roadway. All individuals should wear the proper footwear to prevent potential foot or ankle injury. In addition, those involved with lifting manhole and catch basin covers should wear steel-toed boots and protective gloves. The cover to these structures weigh upwards of 250 pounds and can cause serious harm to underprotected personnel. Only properly trained and authorized personnel should be lifting these covers. All others should stand clear. It is important to note that if an outfall pipe needs to be cleared of dirt or debris, never use your hands. Often outfalls along beaches or muddy waterways require the removal of sand or dirt to fully inspect or collect samples. The water going through these pipes is untreated and often carries debris from roadways. This debris includes glass and hypodermic needles, both posing risks to lacerations and transmission of diseases. Using a small shovel to clear pipes of sand and debris reduces this potential hazard. Some samples may be taken back to a lab or office to be tested for additional parameters. While in the lab, always wear protective eyewear and gloves. Some of the tests require the use of chemicals and can pose a hazardous risk. Gloves should be changed frequently to avoid cross-contamination of samples and hazardous chemical exposure through unnoticed ripping or tearing of the latex. All potential hazardous chemicals are equipped with a safety data sheet. These sheets should be readily available and referred to frequently. The information on these sheets include chemical composition, first aid procedures specific to the different routes of exposure, and the proper grade of personal protective equipment to use while handling each chemical. Any hazardous liquid waste, as well as broken glass ampules, should have a designated waste container and be disposed of in accordance to Section 13 of the safety data sheets. One of the most dangerous hazards personnel may face is entering a confined space. Occasionally, while investigating manholes and catch basins, it may be necessary to enter a confined space. Some confined spaces require a permit to enter. It is important to know the differences between a confined space that requires a permit and those that do not, and the appropriate safety measures to take for each. Only authorized and trained personnel may enter a confined space. A confined space is defined with 3 specific characteristics. A space large enough for an individual to enter and perform assigned work. A space not designed for work over an extended period of time. And a space that has limited restrictions on entering and exiting the space. A permit-required confined space has all of the characteristics of a confined space in addition to one or more of the following. Contains or has the potential to contain a hazardous atmosphere. Contains material that has the potential to engulf an entrant. Has walls that converge inward or floors that slope downward and taper into a smaller area which could trap or asphyxiate an entrant. Contains any other recognized safety or health hazard, such as unguarded machinery, exposed live wires, or heat stress. Before entering any confined space, always check the 3 following elements in chronological order. Oxygen content, flammable gas and vapors, potential toxic air components. If entering a permit-required confined space, personnel must have the proper equipment and the required training. The entry supervisor will need to cover procedures on how and when to exit. The elements previously mentioned to test for before entering the space should also be tested for periodically while working in the space. During the time an individual is in the confined space, he or she should always have contact with the attendee. This will allow for easy communication, especially in the case of an emergency. All of the information previously mentioned, along with other important additional information, can be found in OSHA 29 CFR 1910-146. The safety hazards discussed in the video are among the most common hazards personnel will cross while conducting field and lab work. If an individual comes across a hazard while in the field or lab and are unsure of how to proceed, they should ask a supervisor. If at any time anyone does not feel safe, he or she should not continue. The safety of the participants conducting field and lab work for this program is everyone's #1 priority. This concludes our video on hazard and safety. We hope the information portrayed in this feature will be useful for your future work in this program. Check back soon for more videos on the Buzzards Bay Stormwater Collaborative YouTube channel.